Hi, welcome back to my channel. This week's problem is finding the blue area of the shape you can see in front of you. So I'm going to show you my solution in 3, 2, 1. Okay, now the first thing to do with this problem is to add radii on. Anything with circles is going to be to do with the radii, so add those on. So I did that and I've got this shape at the moment, so it's kind of like an arrowhead. Now, what you might think once you got to this point is, well, first of all, I actually need to work out only one of these blue areas, then double it because there's symmetry there. It's symmetrical, so I can just double it afterwards. The next thing is once I've got these radii on, I might start to think about some segments of circles. So that would be working out a sector and then taking away a triangle to leave me with the segments. So can I do that for the quarter circle for just this section inside of those two radii? And can I also do it for the 5 centimeter circle radii, 5 centimeter radii circle? Can I do that? So I'm going to put this line in and make those segments, identify those by making the triangle. I'm then going to make another triangle here, and that's because I need some length to work out some angles so I can work out these sectors. So I need to work out these two angles here, and again they're going to be the same because the two triangles ACO and OBC are identical. They're what's the word? Similar. They're more than similar, they're congruent, they're just kind of rotated. So they're the same triangles essentially. Right, now I'm going to label the lengths 5, 5 and 10 because the radius of the circle has to be 5 because it's inside exactly a 10 centimeter square, and the length of the other sides have to be, so A to C and B to C has to be 10 because they're the radius of this large quarter circle, which is basically inside exactly the square, which therefore has to have a radius of 10. So then what I'm going to do is I'm going to label OC. Now that's a little bit tricky until you realise that OC is actually half of the diagonal of the square. Again, because of symmetry, it has to be. And so the whole length of that, that's top left to bottom right, or whichever diagonal you do, is going to be 10 root 2, so we're going to halve that to give us 5 root 2 as the length O to C. Now once we've got that, to work out alpha, either one of those angles, we're going to use the cosine rule. That's this rule here, a squared equals b squared plus c squared minus 2bc cos a. I'm going to rearrange that so I can work out an angle. So the angle A is equal to inverse cos of b squared plus c squared minus a squared over 2bc, where capital letters are the angles and the lowercase letters are the sides, and corresponding letters, so capital A and lowercase a, they are opposite, so opposite angle to opposite side. So yeah, that's how it works. And if you're not sure, I'm going to put up, because there's something else I'm going to use later on, I'm going to put up a triangle labelled in that way, so that's what it will be used with, and that's how you'll identify those sides and angles if you're not sure. Okay, now what I'm going to do, I'm going to substitute in here, so B and C doesn't matter, but A has to be, like I've said, opposite the angle. So the angle alpha in this case, can't get my words out, alpha is our A, and lowercase a therefore has to be opposite that, which is 5. So A is the only one that matters, B and C can be 5 root 2 or 10, they're interchangeable. I plug it all in, I get this. I'm then going to work out what that would be, and I get this. That's my answer for alpha. Now that's approximate, but what I'm going to do is I'm going to leave the cos minus 1 5 over 4 root 2 there, because that's the exact version, and so I can use that later on when I need to. I can also store this answer by calculator, so that will help me. Then what we need to work out, this. Now to do that, that is from, well, the whole thing rather, the red and the blue bit that I've identified there. I need to work out the angle between AO and OB, basically the sector of my whole circle in there, the fully blue circle if we didn't have the shape in the middle. Okay, so to do that, I then need to work out this angle gamma. Now to get gamma, I need to work out first of all betas, because again they're congruent triangles, so they're going to be the same. Work out the 2 betas, take away from 360, that will give you gamma. So I'm going to do that. I'm going to work out beta in the same way, but I'm just going to change my labeling essentially here. So in this case, lowercase a, which is the important one, is opposite the angle we want, opposite beta, so that is going to be 10. So I plug all that into inverse cosine rule again, and that simplifies to this, about 110.7 degrees. But again, I've got the exact answer there. Now we're going to work out gamma, like I say, by taking 2 of those away from 360, because angles around a point add up to 360, and I get that gamma is 138.59. So I've got the 2 angles really that I need. Beta at this point probably isn't important. I only need alpha and gamma so that I can work out the 2 segments and sectors, and then taking away the triangles, the 2 segments. Okay, so this is what I was talking about earlier, the sine rule for area of a triangle. I'm going to use this bit next. Now you might know this, you might not, but if you don't know it, the area of a triangle is not just half the base times perpendicular height. You can also work it out this way, which is really the same thing because of the way that sine works. But the way the formula is a half a b sine c. So that is essentially, you've got 2 sides, you times them together, times it by half, and times it by sine of the angle in between those 2 sides, and that will give you the area of any triangle. So let's work out this full segment here, and I'm going to do that by doing gamma over 360, and I've put the gamma, alpha and beta all down bottom right for the moment, just because you might want to refer to them, but this full segment here, and you can still see it on that diagram, that is going to be a segment or sector, of the full quarter circle. Not the full. It's going to be a sector of the circle, the 5 radius circle. It's that sector. So that's why I need to use gamma, because it's of the inside circle, which would all be fully blue if we could see it all. So gamma over 360, because it's that amount of degrees we want, times pi, times the radius squared, which is 5 squared. And then I've taken away the triangle. So that is triangle AOB. I've subtracted that. The area of that is a half times 5 times 5 times sine gamma, because that's the angle in between those 2 sides. So I've subtracted that. That gives us an answer of 21.967. And again, save that for later, store it on your calculator, or you can just put the whole calculation into your calculator in a second. Now we need to do just the red segment. Now just that red segment is to do with the 10 radius quarter circle. So we need to do 2 alpha over 360. We want that amount of 360 times pi times the radius squared, and then we're going to subtract the triangle again. Now the triangle in this case is ABC, so that's a half times 10 times 10 times sine 2 alpha. Okay, that gives you an answer of 7.329, and you probably know what to do at this point. You're going to subtract both of those from each other, gives you 14.638, but don't forget at the end you've got to double it to give you the final answer, which is 29.276. Hope you enjoyed that. I tried to do it a bit quicker this week. Hopefully that was good. If you liked it, if you like me going a bit quicker, talking a bit quicker, let me know. If you didn't, equally, let me know. And I hope you enjoyed the video, and if you're trying it yourself, I hope you managed to get the same thing. I want to say thank you to the people that liked the video last week, because I think that did help. Maybe not to bring people to the video specifically, but I think it helped to promote the channel. But I also really appreciate the support, so I do want to say thank you to the people that did watch the video to the end and did like it. Your support is really appreciated, and we did manage to get over 800 subscribers, which is brilliant. So thank you for that, and like I said, I hope you enjoyed. I'll see you next week for another Mr. Talbot Maths video. Till then, bye bye.